Here we are getting together and doing a few quick things on geometric basics. For the most part, I am not big on you having to know and memorize formulas. This is what the internet's for in your future. So in most cases, we'll either provide them, but let's kind of go through some of the elements of what we're talking about when we're doing geometry. These are, as you have guessed it, triangles. All of them are just drawn slightly differently. When you're dealing with a triangle, in this case, this is a right triangle. So we have a right triangle here. B stands for base, H stands for height. The base and the height are always perpendicular. Just like if you think of an airplane flying overhead, the altitude or the height of an airplane is always straight up or vertical from the base or from land. So in this case, the base would be here, height goes there. In this green triangle, apologize that green's not showing up so well, but this would be the base and the height is going straight up from it. The height in this case is not one of the sides. I have to draw it up as a dashed line, so that represents that it's not the actual side length, whereas in the blue triangle here, the height actually is a side length. And then over here, I've got another one, and the base doesn't have to be the bottom. We can call any side we want the base as long as the height is going perpendicular, that is 90 degrees. And again, that's a 90-degree marking, 90 degrees up to the opposite point or that height. All right, and then what we're doing is we have area formula for a triangle. It can be rewritten a couple different ways. 1/2 times base times height. You could also write it as base times height divided by 2. Totally fine. And if you see base times height divided by 2, it actually looks like base times height. Well, that's a rectangle divided by 2. So if you look at this, this is actually a rectangle. If I extended that over and then down and then divide it in half, these are also they're half parallelograms. We're not going to get into that for today. If I were to find the perimeter, I would have to know the third side. So let's say this third side over here is R, may or may not be. But the perimeter then is the distance around. The perimeter for that triangle, we would use P. P equals H plus R plus B. So perimeter is just the distance around. There we go. Now we have a square. All sides are the same length in a square. So area of a square is side times side, or in this case, side squared. Number times itself is squared, so S squared. Perimeter is the distance around, so S plus S plus S plus S, which is also 4S, 4 times the side length. This is a trapezoid. If you think of your trapezius muscles, I've called that because they do resemble what's called a trapezoid. A trapezoid is when the top and the bottom sides, or the bases in this case. Now this right here, B1, that subnotation, don't get that confused with B squared. Not the same thing. B1 is just naming it first base. B2, second base. The bases are parallel to each other, and then I have these two angles that go on the side. It's called a trapezoid. Anyways, but on a trapezoid, if you want, I can show you the derivation of how this formula comes together. It's not honestly that important, but it is base 1 plus base 2 divided by 2. So you average the two bases, and then you multiply that by the height, and that's the area of a trapezoid. If I knew the other two lengths, so let's call this L1 and L2, because they're different, you can see they're different lengths, then the perimeter would be adding the 4 sides up. Base 1 plus L1 plus base 2 plus L2. There's nothing there that you can combine. It's not a very fun formula, but that's just the distance around a trapezoid. Circles, you've done this a million times probably in your mathematical past. Area of a circle is pi times the radius squared. What is the radius, you say? The radius is the distance from the center to the edge of the circle. The other item that we typically have when we're talking about a circle is what's called the diameter. So if I draw a diameter in there, that whole length from one side to the other is the diameter. So to find the perimeter of a circle, it is pi times d. But if you look at the circle, you can see that, well, d is here to here, which is r, here to here, which is r. So perimeter can also be rewritten as perimeter equals 2r times pi. All right, and then I have c over there. What does c stand for? C stands for circumference, which is the same as perimeter. Pi d, c equals also 2r times pi. They are the same number. Either way you do it, you're going to get the circumference. And again, circumference would be the distance around the circle. Sometimes people wonder, where does pi even come from? If you could infinitely measure a circle, the circumference and the length of the diameter, and if you would take them as a ratio one to the other, you would get the ratio of pi, 3.14159, etc., 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 forever and ever and ever. Amen. Have here a cylinder. Let's draw my radius. Right there, radius. This is my height of my cylinder, goes from the base up to the top. Volume of a cylinder is pi r squared, that circle at the bottom, and then think of it, I just take that one circle and I blow it all the way through the top. So I have a circle and then another circle and then another circle and then another circle, and they're just layered and 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 layered all the way to the very, very tippy top, giving me times h. So I take that radius all the way through, pi r squared times h. Cones is a cylinder cut in thirds. 1/3 pi r squared h. If you'll see, pi r squared h is the cylinder. 1/3 of that gives me a cone. In my picture here, this is my height that goes straight up from the bottom. The radius goes from the center out to the edge, r. So pi r squared times h. Sphere. 4/3 times pi times r cubed. Three-dimensional. I have 3 dimensions, r times r times r. Just like on the cylinder, I had r times h, so 3 dimensions. Couple things left here, moving away from 3-dimensional, moving away from 2-dimensional in terms of area and perimeter. Now we're talking about a triangle. Interior angles of a triangle. The interior angles of a triangle add to 180. So looking at what I'm given there for my angles, I can write down an equation. Running them all down, x plus the 2x plus the x minus 20. When I add the 3 angles of a triangle up, they add to 180. So then I have, combining like terms, 4x minus 20 equaling 180. Adding 20, 4x equals 200, x equals 50. If I plug that back in, this angle is 50. This angle is 2 times 50, which is 100. This angle is 50 minus 20, which is 30. 30 plus 100 plus 150, 180 degrees in a triangle. And then a couple vocab words if you have not seen them before. Complementary means the sum is 90 degrees. Sum is our fancy mathematical term for adding. Supplementary, sum is, that's an S, 180 degrees. Supplementary angles add to 180 degrees. Complementary angles add to 90 degrees. There's your quick refresher, primer, or maybe some of you for the very first time, introduction to some geometric shapes, formulas, a lot of which are going to be very applicable for very, very in-depth problem solving that we'll be doing, that you'll be doing, and also for future home improvement projects. Thank you.